Hello viewers, welcome yet again to another math lesson for the upper basic level, and this is targeting the grade 8 levels, but of course other grades can also benefit from it. And on our today's lesson we will be looking at congruent triangles. Okay, we're going to look at the properties and then how to identify them and so forth. Okay, so going by our first slide here, says triangles which are exactly the same shape and size are said to be congruent. Okay, so triangles which have exactly the same shape and also the same size are what we call congruent triangles. So that's a condition there that the triangles will need to be the same shape and also the same size. Then it says two triangles are congruent if the 6 elements of one triangle, that is the 3 sides and 3 angles. We know that every triangle has 3 sides and also 3 angles. That makes it 6 elements, okay? So we say two triangles are congruent if the 6 elements of one triangle are equal to the 6 elements of the second triangle, okay? Meaning the 3 sides of one triangle are equal to the 3 sides of the second triangle, and also the 3 angles of the first triangle are equal to the 3 angles of the second triangle. Then we can call those two triangles as congruent triangles. Okay. Now going further, this is an illustration here. We have two triangles here. We have triangle ABC, and also we have triangle XYZ. Now if you observe here, what you realize is that if we look at triangle ABC, side A here, okay, side A, let me make it in red, side AB of triangle ABC is equal to side XY of triangle XYZ. So those two sides are equal. Likewise, let me choose a different color. Likewise, you can see that side AC, that should be green, but never mind. Let's leave it as red. So side AC of triangle ABC also is equal to side XZ of triangle XYZ. So you can see already the two sides are equal, but equally, side BC here of triangle ABC is equal to sides YZ of triangle XYZ. So you can see already that all the 3 sides of one triangle are equal to all the 3 sides of the second triangle. All right, that's one quality already. Then also, if you look at the angles, angle B here of triangle XYZ is exactly equal to angle Y of triangle XYZ. Yes, so comparing the angles also, you realize that angle B of triangle ABC, that's this angle right here, is equal to angle Y of triangle XYZ. Those two angles are already equal. Likewise, angle A of triangle XYZ right here and angle X of triangle XYZ are also equal. And then angle C of triangle ABC is equal to angle Z of triangle XYZ. So what you observe here is that all the 3 sides of triangle ABC are equal to all the 3 sides of triangle XYZ. Likewise, all the angles of triangle ABC are also equal to all the angles of triangle XYZ. So that means that these two triangles, that's triangle ABC and triangle XYZ, are congruent triangles. Okay? Now, to prove that the two triangles are congruent, it is not necessary to prove all these 6 qualities. All right? Which means you don't have to get all the 3 sides being equal and all the 3 angles being equal to prove that 2 triangles are congruent. Okay? Any of the following conditions is sufficient to prove that 2 triangles are congruent. All right? So we're going to be looking at some qualities here that if 2 triangles have any one of them, then we can say that those 2 triangles are congruent. So we don't need to prove that all the 3 sides and all the 3 angles are equal all the time. Sometimes one order quality would be enough to prove. Let's see what those are. Now the first one we have is one side and two angles in one triangle are equal to one side and two similarly located angles in the second triangle. So if this condition is met, then those two triangles are congruent. That is, if one side and two angles in one triangle are equal to one side and two similarly located angles in the second triangle, then we can say that those two triangles are congruent. And let's look at that in a diagram. Let's look at triangle ABC here, okay, and triangle XYZ. If side AC here, AB rather, of triangle ABC is equal to side XY of triangle XYZ, these two sides are equal. Observe that this angle and this angle, they are similarly located on the other triangle also, all right? And this angle A here is equal to angle X here, and this angle B here is equal to this angle Y here. So based on that condition, based on the fact that this side AB is equal to this side XY, and also the angle at A is equal to the angle at X, and the angle at B is equal to the angle at Y, then we can conclude that these two triangles are congruent. The angles are similarly located. You cannot say these two angles are right here. If I have put this other angle at the other side here, then that becomes a different story. So they must be similarly located. Both angles must be on these lines that are equal. If that happens, then we can conclude that those two triangles are congruent. That's one condition that can prove congruency. Another could be two sides and the angle between them in one triangle as equal to two sides and the angle between them in the second triangle. All right? So if the two sides and the angle between those two sides in one triangle are equal to the two sides and the angle between those two sides in the second triangle, then again that is proof enough that those two triangles are congruent. Let's look at it on the diagram. Here you have, again, triangle ABC. Between side AB and side BC, there's an angle B there. And side AB of triangle ABC, if you observe and look at the second triangle, which is triangle XYZ, with the angle at Y, you realize that side AB of triangle ABC is equal to side XY of triangle XYZ. Also, side BC of triangle ABC is equal to side YZ of triangle XYZ. And you realize that the angle between those equal sides, that is angle B of triangle ABC and angle Y of triangle XYZ, are also equal. So we have two sides being equal and the angle between those equal sides also being equal. So that's also a proof enough that these two triangles are congruent. Okay, that's also a condition that can prove congruency. Then we look at our third condition. If the triangles are right-angled, that is, if you have right-angled triangles, all right, and the hypotenuse on one side in one triangle are equal to the hypotenuse and one side in the second triangle. That is also another condition for congruency. We know what right-angled triangles are. And also we know that on a right-angled triangle, the side opposite the 90 degrees is the hypotenuse, all right? So here, if the triangles are right-angled and the hypotenuse and one side in one triangle are equal to the hypotenuse and one side of the second triangle, then we can conclude that those two triangles are also congruent. Like this example here. You look at triangle ABC right-angled at B, and you have triangle XYZ right-angled at Y. You observe that the hypotenuse of ABC is AC, line AC. And it is equal to the hypotenuse of XYZ, that is XZ. Okay, so the two hypotenuses are equal. Then their bases here, like the base of triangle ABC is BC, is equal to the base of triangle XYZ, YZ. Alright? So that being the case, this side, the hypotenuse of one triangle being equal to the hypotenuse of the second right angle triangle, and then one side of this triangle here is equal to the similarly located side of the second triangle. So this also is enough to prove congruency. So you can conclude that these two triangles are congruent. Okay? Now note carefully that the following do not prove congruency. Alright? Now we should note that these conditions here do not prove congruency. Alright? A. 3 angles in one triangle equal to 3 angles in the second triangle. Now that alone is not enough to prove congruency. Right? Just because the 3 angles of one triangle are all equal to 3 angles of a second triangle, only that quality alone does not prove congruency. You need more than that, okay? Like this example here, you have triangle ABC and triangle XYZ, and you can observe that all the angles of triangle ABC are equal to the corresponding angles of triangle XYZ. But that alone does not prove congruency. Okay? So that's something you should be mindful of, that just because all the angles of one triangle are equal to all the angles of the second triangle, that doesn't prove that those two triangles are congruent. Then the second condition that does not prove congruency is 2 sides and an angle which does not lie between those or these 2 sides in one triangle equal to 2 sides and a similarly located angle in the second triangle. Now this also does not prove congruency, alright? Just because you have 2 sides and an angle, but that angle now does not lie between those 2 sides that are equal in one triangle. If that's equal to 2 sides and a similarly located angle in the second triangle, this also does not prove congruency. Alright, the sides may be equal, but because the angle is not located between those 2 equal sides, so you cannot use this to prove congruency. Okay, that's another condition you should be mindful of. And you can see it clearly here in this example. In these 2 diagrams here, you have triangle A, B, C. Okay, then you have triangle XYZ. If you observe, you see that line or length AB of triangle ABC is equal to length XY of triangle XYZ. Fine. And also length AC of triangle ABC is equal to length XZ of triangle XYZ. The trouble you have there is that the angle that is indicated does not lie between the 2 equal sides, right? Because these are the 2 sides that are equal to this corresponding triangle. But the angle now, here, it does not lie between those 2 sides. Likewise, the angle here also does not lie between the corresponding equal sides. So therefore, this does not prove congruency, all right? Based on what you have learned so far, let's do some practice, all right? Let's see if you can identify congruent triangles or not, okay? Says here, state which of the pairs of triangles are definitely congruent, all right? So we're going to look at the triangles we are given and see whether we can conclude definitely that the 2 triangles are congruent, all right? Remember the properties we have gone through, okay? So if we look at our first one here, we have 2 triangles, and they are both right angle triangles. So we are dealing with right angle triangles here. First, let's investigate. Their hypotenuses are equal. Okay? So that's one quality already gotten, that the hypotenuse of the first triangle is equal to the hypotenuse of the second triangle. But also, the base of the first triangle here, okay, is equal to the base of the second triangle. You can see that. So what did we say? If the triangles are right angle, if their hypotenuse are equal, and then one of other side are also equal, by the way, there should be similarly located sides. You can see the hypotenuse, equal. The base of this triangle, the base of this triangle, they're also equal, okay? So therefore, we can conclude definitely that these two triangles are congruent triangles, okay? Because they fit one of our conditions. So we can conclude that these two are definitely congruent. Now let's look at more of them. We have C, B, and C here. Let's look at it. We have, for B, we have two triangles again, triangle ABC and triangle XYZ. We know from the diagram here that length AC of triangle XYZ is equal to length XZ of triangle XYZ. We can see that here. Likewise, the length AB of triangle ABC right here is equal to the length XY of triangle XYZ, that's right here. So we do have corresponding sides being equal. But the angle we are shown, does it lie between those two equal sides? This angle here and this angle here. Does it lie between those two corresponding equal sides? Now, clearly, it does not. Okay? So therefore, we can conclude that these two triangles are not congruent. Okay? Because it does not fit the condition for congruency. So although the two sides are equal, but the trouble we have there is that the indicated angle does not lie between those two corresponding equal sides. So those two triangles there are not congruent. Then we go to C. C, again we have triangle ABC, okay? And also we have triangle XYZ. Now all we know is that side AB here of triangle XYZ, ABC rather, side AB of triangle ABC is equal to side XY of triangle XYZ. So these two sides are equal. We can also see that this side here, this side, which is side AC of triangle ABC, is also equal to side XZ here of triangle XYZ. So the two sides are equal. And also the third side still, BC of triangle ABC right here, is actually equal to YZ of triangle XYZ. So what happens here is that all the three sides of one triangle are equal to all the three sides of the second triangle. But the question is that enough for us to conclude that these two triangles are congruent? No, it is not. Okay? We don't have enough just because the three sides are equal, or all the three sides of one triangle are equal to all the three sides of the second triangle. That alone is not enough for us to conclude that these two triangles are congruent. Okay? So you cannot definitely confirm that they are congruent. Then you have D. Let's look at D also very carefully. You have triangle ACB, which is a right angle triangle, and it's right angled at C. Then you have triangle XYZ, also a right angle, XZY rather, also right angle at Z. So let's first look at their hypotenuses. The hypotenuse of triangle ACB is AB, and you can see clearly that it is equal to the hypotenuse of triangle XZY here. So their hypotenuses are equal. Now, do we have any other corresponding equal sides? Yes, we do. You can clearly see that AC here of triangle ACB is also equal to XZ of triangle XZY. So what do you observe? we have two right angle triangles. Their hypotenuses are equal, and one of their sides are also equal. So we can definitely conclude that these two triangles are congruent. Okay? Then we have an E. Again, we have another two triangles. We have triangle ABC. We also have triangle XYZ. Now let's investigate and see whether what we are given is enough to prove congruency. Okay? Now what do we have? We can realize that angle A here of triangle ABC, that angle here, is equal to angle X of triangle XYZ. They are equal. Likewise, angle B of triangle ABC is also equal to angle Y of triangle XYZ. Also, angle C of triangle ABC is also equal to this angle here, angle Z of triangle XYZ. So what happens here is that all the three angles of one triangle are equal to all the three angles of the second triangle. But again, the question is that enough to prove congruency? No. Just the angles all being equal, or just because all the three angles of one triangle are equal to all the three angles of the second triangle, that in itself alone is not enough to prove congruency. So you can say that these two triangles are not congruent because we don't have enough information to prove that they are congruent. Okay? Right. Now let's conclude with this diagram here. Now it says, in the figure below, find the length of AB. Okay? So here we have this figure, you can clearly see. All right? We have a line BD and a line AC, and they intersect at E. And then you have DC here, and then AB right here. You can see that, right? And if you observe carefully, we see clearly that BE here is 2 centimeters. Also, ED or DE right here is also 2 centimeters. Okay? Then EC right here is 4 centimeters. Likewise, DC or CD here is 3.5 centimeters. And we have our AE here, AE as 4 centimeters. Okay? Then we are required to find AB. So we need to analyze this. First, if we look very carefully, you can see that we have two triangles here. You can see triangle ABE, that's a triangle. Also we have triangle ECD, that's also a triangle. Now our task is, can we prove that those two triangles are congruent? Because if you can do that, then we can easily find our AB. Let's see what we can find. If you observe carefully, this angle here, all right, that's angle CED of triangle ECD, and this other angle here, right here, that's the angle BEA. If you observe them carefully, they are vertically opposite angles. We know that, all right? That this angle and this angle are vertically opposite. And we know that vertically opposite angles are equal. So definitely this angle is equal to this angle. But also, by close examination, you realize that EC of this triangle ECD is 4 centimeters. It is also equal to AE of triangle ABE. Okay? So we have definitely they have two equal sides. And also, actually ED here and BE, you can see that those two sides are also equal. So what do you observe? These two triangles, they have two sides being equal, all right? and the angle between those two sides are equal. And if we recall one of our properties, if you have two sides and the angle between them in one triangle being equal to the two sides and the angle between them in the second triangle, we can conclude that those two triangles are congruent. So definitely, the triangle ABE and the triangle ECD are congruent, right? And since we know congruent triangles, their three sides are equal because they have the same shape and size. So obviously, we have shown that actually these two triangles here, they are actually congruent because the two sides and the angle between them of this triangle are equal to the two sides and the angle between them in the second triangle are equal. So we know that these two triangles are definitely congruent, and we know congruent triangles have the same size and shape. So therefore, we have been asked to find this AB, and we can see that AB corresponds to DC. So therefore, if DC is 3.5 centimeters, we can say this CD should be equal to AB, because this triangle is congruent to this triangle, okay? So their corresponding side would be equal, okay? So therefore, if DC or CD is 3.5 centimeters, we can conclude that AB is also 3.5 centimeters. So you can see through careful analysis of the diagram we have, we can easily solve a problem like this if we can prove that the two triangles are congruent. And with that, we come to the end of today's lesson. Thank you for watching. Goodbye.